Hi, I'm Nico Nierenberg, the CEO of Persyst. In this video, I will be doing a short demonstration of Persyst 13, which is the latest version of our software. This demonstration will be done using a standalone version of Persyst, although frequently you will be using Persyst in an integrated fashion with the EEG manufacturer's software. I'll start by opening our database. If you use Persyst with the EEG manufacturer's software, you will open it directly with their database. But we also provide a database, and one advantage of Persyst is that we are able to read almost any kind of EEG format, and all of the formats can be combined in one database. Persyst database is showing the list of patient records, and I'm going to pick out a particular record, a 24-hour epilepsy record, to start this demonstration. The view you are looking at now is what is called a trends view. On the trends view, you see time across the x-axis, just like an EEG page. But unlike a typical EEG page, we are looking at 2 hours of EEG summarized by Persyst quantitative analysis. What you're looking at vertically is a set of trends that each provide a different analysis of the EEG. Sets of trends are organized into panels. Panels and trends can be defined based on your preferences. For example, you can organize panels based on the types of cases that you will be reviewing. For now, I'm going to use what we call a comprehensive panel. It shows a pretty wide range of features. Starting at the top of the page, the first trend is artifact intensity. This shows how much artifact of different types is in the EEG at this point in time. If you look over to the right, you can see that the top line represents the amount of EMG. The second blue line shows the amount of vertical eye movement. And the third shows the amount of lateral eye movement. So very quickly we get some information, which is that this patient is awake. Later you will see how the artifact intensity trend changes when the patient falls asleep. The next part of the panel is seizure detections and seizure probability. They are blank on this page, as there were no seizures during this time period. The next line shows spike detections. This shows a remarkable new feature of Persyst 13, which is the next generation spike detection. This is probably the most important new feature in Persyst 13. What is terrific about Persyst 13 spike detection is that it is very sensitive, but it also has a low false positive rate. Relative to previous generations of spike detectors, it is quite remarkable that way. We are looking at 2 hours of EEG, and there are a couple of detections which you can see in the middle of the page. I happen to know that those are false positives due to electrode artifact, but that's not very many false detections to look through in that much EEG time. We'll get to some more interesting aspects of spike detection later, but one important feature is that you aren't going to get hundreds of false detections, making it more time-consuming than it's worth. The next trend has to do with spike rates, and I'll get to that in more depth in some other records. The next trend is an indication of whether we see rhythmic delta present. This is followed by what we call the Rhythmicity Spectrogram, which is unique to Persyst. There is a trend for the left hemisphere and one for the right hemisphere. We look on the right of the page, and there is the scale. This is going from 1 Hz to 25 Hz. It is measuring the amount of rhythmic activity by frequency from low frequency at the bottom to high frequency at the top. There isn't much happening during this 2-hour period, although you can see a clear posterior dominant rhythm during much of it. The next trend is the FFT. This is sometimes also called CSA. It also goes from low frequency to high frequency, but instead of measuring rhythmic activity, it measures power. Again, there are separate trends for the left and right hemisphere. Next is a very useful trend called an asymmetry spectrogram. This is measuring the difference in power between homologous electrodes on the left and the right at different frequencies. And again, we are going from low frequency to high frequency. On this page, not much is happening. It is a symmetric EEG. And something you should know is that in Persyst, it is like the American political system. Blue is on the left and red is on the right. So this is just sort of oscillating back and forth without much happening. Next is the familiar amplitude integrated EEG display. And finally, the suppression ratio. This is not a suppressed patient, so the ratio will hover around 0. So that is the set of trends on this panel. What I'm going to do now is move forward using this button on the bottom right. I'll be moving forward 2 hours at a time. And that shows how quickly I can review this kind of record. So I've just moved forward 2 hours. And still nothing is happening. The patient is still awake, as you can see at the top of the screen. I move forward another 2 hours, and now some things start to happen. And if we look at the top of the screen at the artifact intensity, we see that the artifact starts to drop off. This patient is getting drowsy and falling asleep. And then we start to get some spikes. The spike intensity is increasing, as you can see in the spike rate trend. These spikes are not artifacts. The spike rate is getting to be greater than 3 per second in some epochs. And the blue indicates that the spikes are maximal on the left. So you're seeing spikes, maximal on the left at increasing rates, and then the patient has a seizure. The patient wakes up briefly and falls back to sleep. And the spikes continue, as we see looking at the rest of the page. If we look at the other trends, we can see related things happening. I'm going to change the time scale so we can see this a little more clearly. Again, this is the same pattern, just zoomed in a little bit. Looking at the rhythmicity spectrogram, you can see the rhythmic activity moving from a high frequency to a lower frequency. And it is more significant in the left hemisphere. The evolution displayed is the hallmark of a seizure, and they will often look the same for seizures from the same patient, a kind of signature. Of course, the seizure detector isn't perfect. It won't pick up everything you might consider to be a seizure. But when you are looking at the EEG, you might notice this kind of pattern in the trends. That means you can look through the trends after that time to quickly find similar patterns, without having to necessarily look through every page of the EEG. The FFT shows the same pattern moving from high to low frequencies. And similarly, the asymmetry spectrogram shows that this is predominantly on the left. You can see the slow activity and how it generalizes. And finally, you can see the increased slow activity leading to the seizure, and after the seizure, it becomes suppressed. Now the activity moves to the right, but that is more suppression of the left than it is increased activity on the right. The AEG shows the seizure as well, with the blue line above the red line indicating that more of the seizure is on the left. So now what I'm going to do is that I'm going to move to the EEG at the same time, and I'm going to switch over to the EEG view. This puts us at the beginning of the seizure. The seizure onset is somewhere in this area, and it continues. You can see how the trends aligned with the seizure activity in the EEG. And now I'm going to show you a very powerful feature of Persyst, which is the ability to remove EMG. This is a very messy image. There is a lot of artifact around the seizure, but with one click of a button, I can turn on artifact reduction. It removes the EMG and moves it to the background in a light gray color. But it has been removed from the EEG signal, and now I can clearly see the seizure. This is not done using a high-frequency filter, and the signal is not being distorted. One way to see that is if you look at this channel here. You'll see there's not a lot of EMG in that channel. And if I turn on the artifact reduction and turn it off again, you can see that the signal is not being altered. This is all done by something called blind source separation, where the signal is broken into its constituent portions. We use an algorithm to determine which portion is EMG, remove that portion, and put the rest back together. The result is a nice clear picture of what is happening. This is a very powerful feature, and it works across a wide range of EEG, and it is useful even when you are just reviewing EEG separately without the trends. Of course, we also use this feature in the trends. When we were looking at these trends previously, the artifact reduction was turned on. Artifact reduction also detects and removes a lot of lateral and vertical eye movement. This means that the trends are computed using mostly cerebral activity and not eye movement, EMG, and electrode artifacts. Those are all removed prior to the trends being computed. It is much easier to interpret quantitative EEG when all those artifacts are not being dumped in the blender and where what you are looking at is actually cerebral activity. If I turn off artifact reduction, this is what this picture would look like. Everything would be a lot less clear. These huge signals at the beginning of the page are not a seizure, it's just electrode artifact. This is the clear picture you get from Persyst, and you cannot get that from any other quantitative EEG product. Another feature of Persyst is spike review. In spike review, we load the spike detections that were made for the record and summarize them by where they are considered to be maximal. We present them so that you can see averages as well as individual detections. This can provide a very quick review mechanism for the spikes that were detected. In this case, we see that there are 1,365 of them, the vast majority considered maximal at T3, and you see the averages of these detections. I can turn a voltage map on. And I can look at the individual detections by clicking on the group title. If I want to see those detections in the record itself, I just click on them and the EEG moves to that part of the record. This is a very quick way to review the large number of spike detections that you can get in a long record, and you can save a lot of time. You can see what the major features are very quickly. Another feature of Persyst 13 is the ability to do automated spike counting. I'm opening a status epilepticus and sleep case. These frequently require hand marking to determine the spike rates. This record has been marked by Persyst 13, and as you can see, the spikes are very consistently marked. The new tool for spike counting is called the Spike Index tool. A section of the record has been marked as slow wave sleep. And we have determined that our epochs are 10 seconds, and the threshold will be 7 seconds, 7 spikes during an epoch. So then all we have to do is click Calculate, and Persyst immediately calculates the number of epochs that exceed that 7 spikes during the slow wave sleep period. That is 96% of the epochs. There are 2,000 spikes during that period of time, a little over 1 spike per second. This can obviously be used not just in this type of case, but in any case where hand counting of spikes is interesting. It can save a lot of time and increase consistency due to the fact that you don't have variation from one human reader to another on different days. Another interesting feature of spike detection in Persyst 13 is the way it can work on ICU cases. I'm opening a lateralized periodic discharge case. As you can see, Persyst is consistently marking the discharges. Looking at the bottom, you can see that it is also accurately determining that these are predominantly maximal on the left side. And so these are lateralized periodic discharges as marked by Persyst. To support long-term evaluation, we have introduced some new trends. This is at a 2-hour time scale. I'll just reduce that to a 1-hour time scale. What you can see here is our new spike rate trend that also includes a color code of which side the spikes are maximal on. The blue line indicates continuing lateralized periodic discharges on the left side. This gives you a good indication that the LPEDs are continuing without having to look at every page of EEG. Above the blue line, you see the rate of spike detections. It shows that the discharges are continuing at roughly the same rate. Here's another record. This is a generalized periodic discharge record. Generalized discharges are marked in green. Red would be maximal on the right, and occasionally the software is determining that they are on the right. But these are pretty much generalized discharges. If I go to some other part of the EEG, you can see them continuing with Persyst consistently marking the periodic discharges, so that they can be tallied up for the trends. Again, this is a very nice strategic overview of what is happening in this case without having to look at every page. Now I'll open a FERTA case, and we've actually included a Rhythmic Delta capability, and so we can see when that is occurring. We can go to the EEG and see the Rhythmic Delta. So the Rhythmic Delta indicator is another one of the trends that is giving you some of the answers about the record directly from the trends. You get the rate of periodic discharges, seizures, rhythmic delta, and suppression, which is also shown if you look at that type of record. And this shows the level of suppression down here, so you can get an idea of suppression as well. So there are a number of ICU trends now in Persyst 13 which go way beyond anything we've been able to do before. And a big factor in that is accurate spike detection. This has been a quick summary of Persyst 13. There are many more features and many things that can be customized to present different EEG features the way that you would like. We would be happy to go through this with you, and we will be doing other videos going through other specific features in depth in the future. Thank you very much.